Okay, let's verify this identity. Remember, the goal is that we want to make the left side look like the right side. So before you start, really look at the problem. Look at the goal side. So this is the goal. And see what you have. I want you to notice that we have a cosecant of x. And over here, we have 3 cosecant of x's. Now this looks like a Pythagorean identity, so let's keep that in mind. But I'm going to focus on this. This kind of tells me what I need to do. I need to break these apart. So I'm going to rewrite this question, and I'm going to write cosecant of x because I like it and I know I want it. And then I'm going to write cosecant squared of x times tangent squared of x. All right, and now it's time to look at our identities. Well, cosecant is square root of x is a Pythagorean identity, and so is tangent square root of x. Cosecant is the reciprocal of sine, so that's something that we could think about. So this could be 1 over sine squared. If we wanted to change this in terms of sine and cosine, we could do that as well. It's hard to know where to get started, and sometimes you just have to dive in and try something. I kind of really want to take these two and change them in terms of sine and cosine and see what happens. I don't know if that's going to help, but that's a good place to start if you don't know what else to do. So let's do that. I'm going to just bring this guy down, cosecant of x, and kind of try to ignore it. And then I'm going to change this into 1 over sine squared of x, and I'm going to change this into sine squared of x over cosine squared of x. Remember, there might be more than one way to solve this problem, but this is a good option. I hope you notice what we have here. We have a sine squared on the top and a sine squared on bottom, and that will cancel out. So we end up with cosecant of x, don't lose this guy that we pulled out, times 1 over cosine squared of x. Now, hopefully you remember what 1 over cosine is equal to. 1 over cosine is equal to secant. So we can swap this out with secant squared of x. So we end up with cosecant of x times secant squared of x. I'm going to bring down our goal, or actually just point to it. And I see that I have 1 plus tangent squared. I am trying to get there. I have secant squared and I have 1 plus tangent squared. And if you notice right here in the second Pythagorean identity, I have secant squared of theta equals tangent squared of theta plus 1, and that is exactly what I want. So I'm going to replace this with tangent squared of x plus 1. That's straight off of the identity chart, and I'm going to bring this guy down, cosecant of x, and I want you to look now. These are the same thing. Now, yes, they're written in different order, but 1 plus tangent squared is the exact same thing as tangent squared plus 1. So we can bring this down and say, yes, we have found and proved this goal side and proved this identity. So 1 plus tangent squared of x, and we can say, yay, we did it.